All right, so we're going to do all three of the multiviews together for 1.2.3. We'll do A, B, and C. We're going to start here. I did add a little bit to our notes because I had a couple questions about the orientation of your front, top, and side, and which one of these surfaces is the front, top, and right side. 95% of the time, this here will be your front view, this will be your right side, and this will be your top view. Generally speaking, if we give you an isometric, it will already be oriented correctly. If we're looking here, and I don't think I was sharing my screen, but that's okay. If you're looking here, this will be your front, this is your right, and this is your top, 95% of the time, okay? I think I did a pretty bad job by giving you an oblique when we don't generally use obliques that often. Normally you'll be given an isometric, and then I should have given you this from the start. So I had a couple questions about that. So now you've got an oblique, got an isometric, and then you've got the layout of the multi-views in your notes, and I will update this for you. So if you want to add this to your notes with the sides labeled on there, that might be helpful for you, or you can come back and do that later. But I did add this on there. And then if I share my screen with you, looking at our shapes, this right here, same thing, going up and to the left, this direction is going to be your front. Over here, up and to the right, this direction is going to be your right side, and then up here along the top is going to be your top view, obviously. And so this will work most of the time. Every once in a while, you might get an object where you're like, oh, that's not the largest, most descriptive side on the front. There's holes in other places that should be on the front where you have to change your orientation, and we'll discuss that later on. But for right now, this will be your front, this will be your right side, and this will be your top, okay? So we're going to start here. I did go ahead and put the 3D models into Onshape so we can reference those back and forth, so you can kind of get a better idea of where your front is and kind of what it looks like and where those lines are projected. If we weren't online right now and we were in the classroom, I'm not sure if you guys remember, but put yourself back to elementary school again. We're not drawing rectangles this time, but put yourself back in elementary school where your teacher had that overhead projector and those clear pieces of paper, and they would write on it with those vis-a-vis markers and then have the little spray water bottle and wipe it off. Those things, if we were in class, I have some of those, and I would print out a template for a box. And the template for a box will look something like this right here. So if you're looking here, it makes the little T, and then you would fold up the sides, and then it would make a box. And then our box would be clear, and you would put an object inside of it, and then you would be able to rotate your cube around to see each of the surfaces. This would be your front, this would be your top, this would be your right side, and then in addition to that, we would have a back, a bottom, and a left side. Although traditionally we only need these three. Sometimes you need a couple more, sometimes you don't even need those three, but these are the three ones that we usually use. So you would get to do that and experiment and be able to see firsthand what each of these surfaces look like. So we're going to try our best to wrap our heads around these concepts without doing that. Now that I'm realizing how beneficial this whole situation was, unfortunately, but it's okay. We're still going to make it work. So looking back at these objects, this is going to be your front, your right side, and your top. So if I look at the 3D model of it, maybe. Here we go. All right, looking at the 3D model of our first one, if you rotate to each one of the surfaces, here's your front, your top, and your right side. And you'll see that you have this odd inclined plane surface right here, shaped like a triangle. And your triangle is going to work a lot like a hole or an arc or something, where you can only see its true shape in one of the views. So with a hole, you'll see a circle in one view and rectangles in the other two, kind of like your Coca-Cola can, a circle in one view and rectangles in the other two views. This will work the same. So in two of our multi-views, this triangular shape will just look like a rectangle or a square. And then in the third view, it will look like an actual triangle. So just be aware of that whenever you're working with the shapes. I'm going to cheat for you just a little bit and let you see the front here, and you'll be able to see that you can see this profile, you can see this profile, and then you can see this rectangular shape of the triangle, because this edge is brought forward to be level with this one. Remember, we can't see depth from the front view, so this line here is brought forward, this profile is brought forward, and you can't really tell that it's further back. You can only really see the width of this triangle, not its actual incline plane. So let's get started there. So looking at this shape, I have overall dimensions of 8 by 9, which makes a nice little rectangle. And my objects are way too big for my shape, or for my camera and paper. So I'm going to scale mine down. I had some questions earlier about if you could scale yours down, and some people asked yesterday. So you're welcome to scale yours down like I'm about to do, and I'll try to tell you the true dimensions and then what we're scaling it down to as we go through. So I'm going to start up here. Zoom out a little bit. And then my depth is 2, 4, 6, which is important. So I'm going to just map out a couple of things. All right, so my overall height of my shape is 8. So I'm going to do 4 blocks. I'm dividing all of my units by 2. So 1, 2, 3, 4. So 8 tall. If you're doing it full scale, that's perfectly fine as well. So you'll do yours 8 tall. Our pictures will look exactly the same. Yours will just be a little bit bigger. By 9, so I'll do 1, 2, 3, 4.5 instead of 9, and make a nice clean rectangle like that. All right. Then we're going to look back at our shape again, and you'll be able to see that you'll see this profile here, you'll see this profile here, and you'll see almost kind of like seeing the back. So like if you bring this forward, you'll see that profile there. I'll show you the 3D model one more time so you can see there. There's that first profile, the second one, and then the inclined plane. So looking back at our shape, or on my paper, I know that this first profile, this tall rectangular one, has a width of 2. So I'm going to go 1, and then goes all the way from the top to the bottom. So there's no interference of any sort on this first profile. Okay. Then we're going to add in that inclined plane surface, or that triangular surface. If you look back at your shape, it starts 2 units from the top, Mine would be 1 because I'm dividing everything in half. And then it has a width of 5. So mine would be 2.5 blocks. So right here. So down to over 5 would be about there. And it goes all the way from the left and down like that. So thinking back to those profiles we were talking about when we first started out, here's your first one, here's your second one, and here's your third one. All right, now, same rules apply as always. We'll take each vertical edge or corner and transfer it up. So I'm going to transfer this one up, this one up, this one up using construction lines, and then this one up. I like to leave 4 units of space in between my top and my front and my side. So I'm going to count 1, 2, 3, 4 units of space. This will be the front edge of my top view. And then my object has an overall depth of 6, so I'm going to do 3. So that would be back here. So here's the back edge of the top, the front edge of the top, the left, and the right edge of the top. And each of these vertical edges came from this front view right here. All right, now we can start outlining some information. I have some other depth measurements on there as well. If you look here and look back at the object, I'll share again. If you look back at this object, you can see this piece here has a depth of 3, and then your triangle is the other portion of this piece. So we're going to go in to here and then into here. I think I might have said 3, so I apologize. This has a depth of 2. This has a width of 2, which we transferred up. So I'm going to start with this little L shape here. I'm going to outline the back because it goes all the way across like this. And then we're going down to, in my case, 1, and then we'll go in to where this edge begins. Right there. Make sure you leave a gap right there. And then same thing on the left side. So carry that down. It has a width of 2, but we get that information from right there already. And then you can just connect to get that L-shaped figure. Okay, now if we look back at our figure one more time, you can see that from the top, you'll be able to see the shape of this triangle right here. Shape of this triangle. You can see that this distance here, because on the top we have width and depth, it has a width of 5, and it connects from this corner right here. So we'll draw this line. So we're going from this corner to here, which is in 5 or 2.5 in my case, but I projected that up so you don't even need to measure it. You'll just connect those two. If this information is correct, then this information should be correct. And that completes your top view. And then I'll go in and clean it up some, especially for you, so that you're not confused by any of my stray lines. Like that. Give you a second to get caught up. All right. Now we're going to repeat the same process as before, except instead of transferring vertical lines, we're going to do horizontal lines over to our right side. So take each of your horizontal lines and send them over like that. And then I like to leave 4 units of space. So 1, 2, 3, 4 units of space, roughly right there. And then my depth is 6, so that would be 1, 2, 3 for me. If you're doing it full scale, then yours would be 6. All right, now if you want to, you can use a miter line going up and to the right 45 degrees, or you can just map it out. These are pretty simple, so it's probably easier just to map it out. If you look here, we measured this out and it was 2 units from the back end, this depth measurement. So you'll need 2 in here as well. Mine is half scale, so I'm just going in 1. I'm gonna go ahead and draw that vertical line with construction lines and use it. And then I'll decide how dark it needs to be or how long it needs to be in a bit. And then you know that this measurement came already when we did the overall depth of the shape. Okay, so now we've got our horizontal lines and our vertical lines, and we just need to decide what is what. So I'm going to start with this same rectangular shape here that I started with on the back. I'm going to start right here. So we've got that entire rectangular figure that we can see. There's nothing special really happening on it right now, like that. And then I'm going to share the shape with you again so you can see exactly what we just drew. So that we drew this, and then we'll need to draw in this profile, and then we'll draw in this profile. Okay, so now when you're looking in this way or looking in this way, we can see this profile at the top, and we can see it has a depth of 4 and it has a height of 2, which would be right here. So it has a depth of 4 and a height of 2. That height we already transferred over, and that depth we transferred over as well. Okay, and then we'll need the last rectangle for our triangular shape. Remember, it'll be a triangle in one view, rectangles in the other two. It has a depth of 4, which we already have, and a height of 6, which we already have. So we'll just need to go in and darken those, but make sure that you don't cross this line here because there are no edges happening on this profile here. There's no edges happening here, and then this one's solid as well. And once you get that, you can go in and clean it up. And that will complete our first multi-view for 1.2.3a. And I'll write that on the for reference. All right. Now, if you guys are ready to proceed, we'll move on to the second one. If you have questions, then feel free to put them in the chat. All right, so I'm going to share my screen with you again. Looking at this shape, we're going to start with the front. So this is your front, this is your right side, and then your top is up here. When you're looking at the front, you'll mainly see this back profile. It has a height of 5, a width of 8, up 4, over 4, up 4, over 4. I'll show you on the 3D model, particularly from this view. So you see it has a height of 5, width of 8, 4, 4, 2, 4. Good question. When you found the length for the triangle on the front view, did you find the hypotenuse length or the horizontal or straight length? Horizontal length, the horizontal length. So basically like the base of the triangle, you cannot tell the length of the hypotenuse unless you are looking at it from the triangle being a triangle. So I'll stop sharing for just a second and go back to that. You're looking here. The only place you can tell the length of this hypotenuse is from this top view. And honestly, the length of it doesn't even really matter. You'd never dimension this length at all. Under rare circumstances would you dimension it. Usually just want the width location and the height location, and then you would just connect the two. So this distance there isn't really important. We mainly want to know this. And so these are the same thing. I didn't really use the hypotenuse length anywhere. Good question, though. All right, so looking back at our next figure, you'll see that we can see this whole perimeter of this profile with some other stuff inside. So let's just start with this perimeter first. I'm going to start here. It has a base of 8, so I'm going to go 4 because I'm doing half scale. It has a height of 5, so I'm going 2.5. And then we're going over 4, down 2, down 1, over 4, down 1, over 4, down 4. So your dimensions are probably 8, 5, 4, 1, 4, 4. Mine are 4, 2.5, 2, half, 2, 2. So just be mindful of that. All right, now if we look back at our shape, you can see that you have this triangular surface here. Notice nothing special is happening here. And just like before, you'll really only be looking at the distance of the base. It goes all the way from the left and all the way to the right. And there's no vertical edges happening along here. So when you're looking at it from the front, it will look shorter than it actually is. You won't draw like the length of the hypotenuse. And then same thing here. Notice the height of this triangle is 3. It connects from the top edge down to the top of this triangular piece that's sticking out. And then it has a width of 2. We can't see the true length of the hypotenuse here. You'll see the hypotenuse of this one in the side and the hypotenuse of this one in the top. Remember, anytime you have something like this, you'll see rectangles in two views, shapes in the other. So let's go back to our drawing. The height of that triangular piece sticking out is 2, so we're going to draw it at 1 on mine. You may have 2 and go all the way across. There's nothing special happening here. So this surface is going to look shorter than it really is. And then your triangle that sits right here, it goes to the right 2, so on mine it's going to be 1, and it has a height of 3, so mine is 1, 2, 3, so 1.5. And notice it connects perfectly to where this triangular piece starts, although we can't see it as a triangle right now. So I'll give you a second to correct anything if you need to. All right, now, same process as before. You will take each one of the vertical edges and or corners and project them up. Make sure you get all of them. That way, when we're finished, you can go back and check your work to make sure you didn't miss anything. So I've got this one, this one, this one, and this one. I leave about 1, 2, 3, 4 spaces in between. And then my object has a depth of 2, 4, 6. So I've got 1, 2, 3. My whole figure is going to be in that space. All right, now if you look back at the shape, I'm going to try not to switch back and forth so many times. The depth of this section on the back is 2. The depth of this triangle is 2, and then the overall depth of this triangle is 4. So 2 of this 4 is going to be this part, and then you got 2 more on the end. That gives us a total of 2, 4, 6. That's where I got the overall depth from. So here I'll have 2 for the back, 2 for that little triangle, and 2 for the other one. And now we're going to start filling in some information. I'm going to start just like I did here with this back profile. I'm going to start with that same information back here, which would be this rectangular shape going across here and going across here and closing that off. This and this original profile are essentially the same thing. All right. Now, our next piece is this little triangle piece right here. It has a depth of 2 and a width of 2. So that's it right there. Remember, rectangle, rectangle. Over here, it'll be a triangle. And then this one will be rectangle, rectangle. Here, it's a triangle. So it comes out 2 more right here and then connects all the way to this edge. You see how it connects from here to here? It'll connect from here to here as well, but this time we can see the actual hypotenuse. Some good math vocabulary there, and that will give you your top view. All right, so far so good. So then you can go in and clean it up. Get rid of those stray marks and construction lines. Send those construction workers to their next job. And then we'll repeat the same process. This time, instead of going vertical and projecting up, we'll take horizontal and project over. And this will give you all of your height dimensions for your side view. So make sure you carry each of them over. I like to leave 1, 2, 3, 4 units in between. So there's the left edge of the side, and then the overall depth of the shape is 6. So I'm doing 1, 2, 3. All right, now, same as before, I'm going to start with this profile. Remember we did this overall front profile, and then we did this back section. Oh my goodness, we almost made a mistake. I didn't go back and check my work. I transferred this up, I transferred this up, and I transferred this up, but I didn't transfer this. There's a break here between this level and this level on the back. So you'll need this edge to come up here. Completely forgot it. My apologies. I even erased that line like I had actually used it. So now that I did that, coming back over here, we're going to start with this profile here. Remember we did this back section and then we did this one first, and we're going to be looking at it from this direction. I'll share the object with you one more time. We'll be looking at it this way. So from here, you'll see this profile and this one sitting directly on top. You'll see this triangle, and then you'll see this bottom one as a rectangle. So first, I'm going to outline here. So my depth measurements are 2, 2, 2. So 2, 2, 2. And I'll outline this over here on the left, or on the right, sorry. It's right here on the right. And then when you bring this over, you'll need an object line right there representing this situation, where this piece is higher than this piece. This line lets you know that this section is up higher than this section. So you can't tell anything about the depth, but you can tell about their heights. Okay. Now we can go ahead and do this section. So just like here on the front, you could see that it went from edge to edge and had a height of 2. This one will do the same thing. It'll go edge to edge and have a height of 2. We transferred those dimensions over already, like that. And then once we get these, I'll show you from the side again. And then last step, you've got rectangle, rectangle for the triangle piece. And so now we're going from this corner. It has a height of 3 and a base of 2. There's our point. We've already got it marked. And you'll just connect with that diagonal. And then you can go in and clean it up. I don't think I missed anything this time. But a way to go back and check every time, just like you would check your work with math by going backward, like working it backwards, just carry these lines over and make sure that you've used something as a corner or an edge somewhere. So make sure you use everything. And then that is your second one. Oh my gosh. All right, so last one, unless you guys have any questions. Move on to the last one. All right, last one. Let's knock it out. This guy right here. So I told you guys at the beginning that 95% of the time, this will be your front, this will be your right, and this will be your top. But you can look at this and quickly identify the fact that this top view is actually your largest and most descriptive instead of this and this. It also has an arc in there. It also has cutouts. It has lots of details here that these two views are not going to show you, so we need to change the orientation. Instead of looking at it from here, see if I can get this to rotate. We want to look at it from, nope. Nope. We want to look at it from here. Here. Okay. So this will be our front. This will be our top. And then this will be our right side. Okay. We're going to change the orientation a little bit. If you did yours not this way, you're going to need to fix it and then resubmit it. So let's start with this profile. Also, when you're doing the 3D model, you'll just make this profile and extrude. So you have one sketch and one extrusion. So we'll do this entire perimeter profile. First, add our detail lines in there, and then we'll project it. So let's start there. Stop sharing my screen, and I'm going to try to make sure I don't mess up these dimensions. So looking here, we've got the base of our shape is 7, so I'm going to go 3.5, and then it goes up. Let me go back. We've got 3, and then a gap of 2, and then 3 again. And then keep in mind that this object is symmetrical. So we're going 3, that will be 1.5, 2, so leaving a gap of 1, and then 3 again, so I've got 1.5, and then 7 along the top, which would be 4.5 for me. And then this angle piece, we're going down 2 and over 3, up 2 and over 3. So we'll connect those. Notice I don't really care about the length of these lines. I care about their starting and ending locations. And then we're going down 1, up 1, and 4. And connect. And then this one for last, this one goes in 2, so 1 for me. And then the arc has a radius of 1, so I'm going half. You would go 1 if you're doing it full scale, and then arc it around. Like that. A little messy, but that's okay. Okay. Then also you're going to want a center line. We discussed how to draw those. You don't want to go left with it because it's an arc. You only want the 3. If this were a circle or a hole, you'd want to go left with it as well. And that takes care of that piece. And then same process. We'll project up, do all of that one, and then we'll project over. So let's project each of these vertical lines, corners, edges, center lines, boundaries, all of it. If this were a hole or a circle, you do the left boundary up and the right boundary up, or the top over and bottom over. But since it's just an arc, you only get the right side of it. So we're going to go up here, this one too. And then we're doing up here, here, and here. So I projected over 1, 2, 3, 4, 5, 6 lines. 6 lines. I'm leaving 4 units in between. And it has an overall depth of 2, so for me it'll be 1. All right, now if you look back at your shape, this one we don't have to flip back as much. From here, you can see the surface, and you have a line dividing the two. So if I'm looking here, I've got a whole line going all the way across. Notice if you're looking into it this way, there's no holes missing that are going all the way through that would cause some sort of gap in between these lines. So you want it solid all the way across. And then you want to identify this visible edge or these visible edges, depending on which way you're looking at it. You want to identify that with an object line. All right. Then, if we're looking here, if you look here, if you were looking on the outside, you wouldn't be able to see this cutout, but this edge is still there. If you can't see it, but it's still there, then you still have to identify it. So we carried this line up, and instead of using an object line, we'll use a hidden line. We're almost done. Okay, same thing over here. If this were a hole, you would have a right boundary and a left boundary, and it would look like a rectangle with hidden lines. You don't have a boundary over here, so you only need to use this one, which we already carried up. That would also be a hidden line. And then don't forget your center vertical line, long dash, short dash, long dash. All right, now, same thing as before. This time we're transferring dimensions over to the right. So take each of these horizontal lines and corners and project them to the right. How do you define the center? So if you look at the shape, looking back at it, its center would be about there, right there. You can see it has a radius of 1, so that's where its center point would be, looking at the grid. So I'm projecting each of these over. Don't forget all the corners, all the centers. And don't worry, you'll get better at identifying this stuff the more we practice with it. And same thing as always, I leave 4 units of space in between, and then my overall depth is 2, which mine would be 1 because I've scaled it down. All right, now, same thing as before. If you look at it from the side, notice you don't have any cutouts that go all the way through the shape at all. You have some in there, but they don't go all the way through. If this cutout were to go all the way through, then this would be a different conversation to be had. But you can see surfaces the whole time all the way across. So for our side view, it'll be a rectangle just like our top. I'm going to outline in object lines the boundaries that we already identified by transferring our dimensions. And then just like up here, we have this corner that's visible right here, and this corner that's visible right there. Intentionally skipping these two for a second. What you'll notice here is that this corner and edge is also in line with this hidden figure back here. If this were not here, this little cutout here, you would simply be identifying this cutout with hidden lines very much like you did up here. However, you have a visible edge in front of it. When we talked about precedence of lines last week, we discussed what would happen if you had 2 different line types fall directly in line with one another. Which one would you show? Because of our precedence of lines, our object line is more important than our hidden line. So we will demonstrate this situation with just an object line. Your object line is thicker than a hidden line, so you won't even be able to see it behind it. And then if you go through, make sure you used all of your lines. You will see that we're only missing our center line, which you'll need a long dash, short dash, long dash for your center line. And then that's it. So you can go in and clean it up. Get rid of those construction workers and lines. Like that. And then that's the final result.